Hi everyone. I'm going to go over how to do some dilution calculations so that you have a chance to look at it, process it, think about it overnight, and then we're going to go over these more tomorrow during class. Okay, so first of all, in these notes that you'll find on Class Notebook, I've already filled in the definition of concentration and did a review practice question from what we should know from our molarity, or sorry, from our moles and stoichiometry unit. Okay, so please take a look at that. Now, the real thing that we need to look at here for this unit is what happens when I am diluting something. Okay, so oftentimes we do need to dilute solutions, or you can think about it as needing to dilute some concentrated orange juice. And so one of the easiest ways to do this is that we just mix things with water. Now, to just keep in mind, our molarity is equal to the total number of moles. Okay, and so just like if I was adding water to a mixture of orange juice, the amount of orange juice isn't going to change. And so the total moles in this case of a substance doesn't change. But what does change is the total volume. Okay, and so we need to look at what is my initial volume and how much water am I adding to it when we look at the actual total amount of volume. Okay. And so that's one thing to keep in mind there. And that's what we have down here. The total amount of moles is not changed. What is changing is the final volume and therefore the concentration. Okay, and so the formula that I'm introducing for this is the initial concentration times the initial volume is equal to the final concentration times by the final volume. Okay, and this is the important formula for my dilution calculations. All right, now let's look at an example because this is going to make it easier to understand what's happening. So here for our first example, we start out with 200.0 milliliters of 0.500 moles of, or molar of sodium chloride, okay? And we're adding to that 300.0 milliliters of water. We're saying, what's the resulting concentration of sodium chloride? So let's write down my knowns and unknowns so that we are clear about what we have happening here. So my initial concentration, we're told, is 0.500 molars. And my initial volume is 200.0 milliliters. Now remember, we need to have my volume in liters. And so I'm just going to convert it right now into liters and make sure you still have the correct number of sig figs here when you do that. Okay? And then we're being told that we're adding 300 milliliters of water. Okay, and so my final volume is going to be the 200 milliliters of the sodium chloride and the 300 milliliters of the water. Okay, and so I'm going to have 200.0 milliliters plus 300.0 milliliters. Okay, so my final volume, therefore, is going to be 500.0 milliliters, which again, let's just convert that directly into liters, which is 0.5000 liters. Okay, so now that we know my knowns, it says what is the resulting concentration of sodium chlorides. So my unknown is my C final. Okay, I'm going to make this a little bit smaller here. Okay, and then so now that we have my knowns and unknowns, let's look at the actual formula here. And so we have the initial concentration times the initial volume is equal to the final concentration times the final volume. And let's rearrange this for my final concentration. Okay, so I have my final concentration is equal to C1 V1 divided by VF. And now I can just substitute the values in and end up with 0.500 mole times 0.2000 liters divided by my final volume, which is half a liter. Okay, but again, we're paying attention to my sig figs. And so therefore, the final concentration of my sodium chloride is equal to 0.2 0.00 moles. Okay. All right. And so my question had 3 sig figs here, and so my final answer needs to have 3 sig figs as well. Okay, now we can do something similar but kind of in the opposite direction. And so the question here says, what volume of 6.00 molar hydrochloric acid is used in making up, so what volume, and here's my initial concentration, is used in making up 2.00 liters of 0.125 molar hydrochloric acid. This is a really practical question because this is exactly what all your chemistry teachers are doing when we're preparing for a lab for you. We order things in more concentrated amounts and then we dilute it down ourselves to get to the actual concentration that we're going to use in class. Okay? So again, let's go through our knowns and unknowns here and figure out what this volume is. Okay, and so we're told that my initial concentration is the 6.00 moles, or molar, sorry, 6.00 molar. And it says what volume, and so that means that my unknown is my initial volume. Okay, and I know that I end up with a final volume of 2.00 liters, and I know that I end up with a final concentration of 0.125 molar. Okay, so now again that we know my knowns and unknowns, let's look at my formula. C initial, B initial is equal to C final, V final. And I'm going to rearrange it so that I can solve for my V initial. So I have V initial is equal to C final, V final divided by C initial. Okay, and now I'm just going to substitute the values in. And so I have 0.125 molar times 2.00 liters divided by 6.00 molar. And so you can see here, I didn't show this above, but we should be able to, in each question, see how the units work out and see that I'm left with just liters. My molarity cancels each other out and I'm left with liters, which is what I want for a volume. Okay, and so I get my final answer of 0.0417 liters. And so that's my initial volume. Now I just want to explain what this actually means from a practical perspective for a second here. So it means that I go into the back prep room and I say, hey, I need 2 liters of this diluted amount of hydrochloric acid. I do these calculations, and what I would get is I would get a volumetric flask, okay, and I would have it be at 2 liters, okay, whatever the precision amount is for that specific volumetric flask. I would measure out my initial volume, and so essentially 42 milliliters here, the 0.0417 liters, and then I would fill up the rest with water. And that's what this question is saying that I'm doing, okay? So I'm taking a small amount of this concentrated hydrochloric acid, I'm putting the remainder in as water, and I end up with 2 liters of this diluted amount of hydrochloric acid. All right, so we're going to be doing some more practice of this tomorrow during class. You'll have time to work on some of these practice questions, but you may want to look at a couple of them now ahead of time. See you all tomorrow.